Hi, I'm Francesc Campoy, and this is Just for Funk. Welcome to episode number 29 of Just for Funk. Today, which is by the way Tuesday, because now episodes will be on Tuesday, but more on that later, we're going to review some code. And not only that, but actually I'm going to try to apply a specific concept, which is something that some people call inversion of control, but most people know as dependency injection. They're pretty much the same thing. We're going to apply that concept to our code, a repository that Daniel, what's his name? His name is Daniel Gerlach or Gerlach or Gerlash or Gerlash. I'm not really sure. But anyway, Gerlacdt on GitHub. He sent me on form.justforfunc.com. He sent me his repo. He told me, hey, could you review this? And the thing is that I already sent him a big PR. And it took me probably an hour or so to review the code, which is cool, but I didn't want to make such a long episode. So instead, what I'm going to do is I'm just going to talk about the most important part, which is the part about how to improve testing and applying dependency injection at the same time. Does that sound fun? Let's get started. Okay, so I already got my code here, and you can see that there's some package code with config, db, and version, and then a comments directory with server and main.go, which is a pretty good way of doing things. I think there's a pretty decent way of structure things. On top of that, we also have a make file that has a make build. And when you do make build, it of course does not compile. Why? Let's try to simply do a go run command server main.go. Well, that package does not exist, which is interesting, but it totally makes sense because actually for some reason I'm assuming he changed the name of the repository at some point, and that's why this does not work. But let's fix it. So I'm going to change really quick. So we're gonna use set, and I'm going to change db example by db key value store everywhere in Go files and also in make files. Actually, there's only one make file here, and if we grab db example anywhere, we should not find it anywhere. Yeah, no, we don't have it. Cool. So now we do make build. That now compiles. Okay, so what this package implements is basically an HTTP server, and that HTTP server uses a database, and that database uses files, right? So you basically have file, like a file, os.file, and you're gonna read and write in order to manage a database. And then you're gonna use that database, set, get, and delete to serve basically key value store from HTTP, and also protocol buffers. It's a pretty interesting code. You should check it out, definitely. But instead, what we're gonna do is we're gonna try to see how to simplify it, especially how to make it better regarding tests. So let's see the tests first. Let's see. So the tests right now, the way they work is for every single test, and there's a bunch of them because as you can see, there's db underscore test, handler underscore test, and service underscore test. So a bunch of different underscore test files, which is good. That's very good practice to have unit test. I love that. But let's see what it does. So when you create new DB, that is going to create a new file unless it already exists. And in this test, what we want to do is we want to make sure that every test case has a new empty database. So before, what it does is it deletes the file name if it exists. And then tear down, it deletes the file name too, right? So basically what we do is at the beginning, we delete the file. Therefore, when we call new DB, that will create the file and it will be empty. And then once we're done, we delete it again. And this is okay, but there's a problem, which is what happens if we make our test parallel. So right now, if we do a make test, those tests pass. But if we do, let me edit all of these tests at the same time and do t.parallel. When you call t.parallel, you're basically saying that this test could be run in parallel. And now we do make test again, and it works. And this makes me think that probably there's, let's see our make file. Our make file is doing go test. And I actually think that go test should always have dash race, because you want to make sure that there's no data races. So let's do make test now. Okay, it now doesn't pass, which is actually expected. It says key does not exist. It doesn't really detect the data race. But basically the problem is that somehow now we're actually deleting a file a little bit too early. All of the unit tests are using a single file, right? So that's kind of dangerous. So let's change that first. What I'm going to do is I'm going to create a function that's going to return a path, and then the tier, and it's going to return the path of the file we should use, and also a function, the tier down, that will delete it. So let's go at the beginning. I'm going to delete all of these functions because I don't think they're that important. Also, this should be a constant, but we're gonna call it setup, and given a t, testing.t, it's going to return a string and an empty function, which is the tier down. So we're going to create a temporary directory, ioutil.tempdir, not prefix and no name, because we don't really care. This will just create a random directory inside of temp that will do an error. Did that work? ioutil, yes, okay. And if the error is not nil, since we have the t, we can do t fatal f could not create temp directory, and this is the error. Otherwise, we're going to return the directory. Actually, we're going to return filepath.join the directory and testdb, this thing here. And I don't want anyone else to use it, so I'm gonna move it inside. And tier down, and tier down is a function that what it does is it deletes that directory. So os.remove all directory. And we can probably do it like this. Cool. So now we need to change all of this code, and I'm going to do it with multiple cursors, which you will not be able to really see because it's multiple cursors and my screen is not that big, and probably I will speed it up because I'm gonna take a little bit of time. So let's do it. Okay, so now it looks like it's working, which is cool. So now the problem is that I think that now we're not doing test.parallel anywhere. So what I'm going to do, rather than adding everywhere, I'm simply going to add it here. So all the tests are now marked to run in parallel. And it fails. Ooh, nice. T.parallel call multiple times. Oh, okay, that's not good. Where T.parallel, oh yeah. Actually, I'm gonna remove all of them just in case, and then add it just here. Okay, let's run again. Cool. Okay, so now it runs all of the tests in parallel using the arrays, and it does not fail. Because rather than using one file for all of the tests, we're using one single file per unit test, therefore breaking any kind of dependency, interdependency. Cool. So now that we have that, how can we make this better? So db is probably not my favorite name. Let's name it actually. I'm going to rename the symbol to db, capital B, because it's like ID for identifier, db for database. It should both be capitalized in order to make it idiomatic. And this takes a little bit. But also this function here that we have at the bottom should be at the top. But I don't want to change it yet. Let's wait. Okay, it actually worked. Cool. So we're gonna move it closer to typedb. And what this does is it creates a file, and it creates the file as OS. So it opens the file twice for some reason. I'm not really sure why. But actually, I don't think that that is important. But it keeps The file, so the OS file keeps it twice as a file write. And let's see how do we use that. Let's see all the references. So file write, it's so that's the initialization. We use it seek, and we use it for bytes. Cool. And then the file read is found the references. We use it for initialization, seek, read, seek, read. And I guess that you might know where I'm going. This could be an IO write seeker, an interface. And this could be an IO read seeker, another interface. And the test will still pass because we have not changed really anything. But now what this makes me think is that, well, rather than having file read and file read, let's just have a file. And let's have a read write seeker. Right? This interface has the three methods: read, write, and seek. And we're simply going to do ff. This is going to be f. We're going to do instead of write only, we're gonna do read and write, and we're gonna drop this line. Cool. Now the last part I want to do is, and this is where dependency injection comes in, is right now the DB package knows how to create files, which, you know, it's not bad, but kind of makes it harder for us to test, because in order to test the DB, we need to pass a file. What if instead of creating the file inside, we passed a file into it? So what we're going to do is f os.file and come back to main.go, call, we'll change that later, but fos.file, what is this complaining about? File name. Oh, the file name, we don't need it, so we're just gonna delete it because nobody cares about the file name anyway. Now when we do make test, this will definitely fail because we are trying to do file write and file read. So let's fix those. All file write should be F, and all file read should be F too. Make test. You cannot use tab string. Okay, so the thing is that now in all our tests, we were calling, we're getting a string and passing the string to newDB, and now we need a file. So what I'm going to do is actually just change that. So I'm going to do os.file, and we are going to create, so IOTIL temp file instead. F is going to return F, and our teardown is going to delete, so close the file, and also os delete of file.name. Remove of file.name. What is the problem with this? Oh, file.name is a function. Okay, so, and we don't need this anymore. So now this actually returns a file rather than a path. And when we call teardown, it will close the file and delete it directly. Make test. Not happy. Can I use file name type string in handler.go? Oh, okay. So now the problem here is that the main handler, so this handler creates a service, and so a handler has a service and the service has a database, right? And in order to create the handler, we pass the file name, and then the file name uses creates a service given a database that it creates itself. So what we can do is use dependency injection. You got it. So what we're gonna do is we could get a service. So let's do that. Service is service, a pointer to service. And what we're going to do is, so let's call it service. That way we can use the same name. And that's it. Now, make test. It will complain because handler test, main.go. That's main.go, we don't care about it yet, but let's fix the test first. So we need to pass new service of testDB of new DB of testDB. That starts to be quite ugly, but let's leave it like that. And I think that probably here we're gonna need the same. Make test. Main.go handler test. Okay, we're gonna need the same here. Okay, so our test pass. Main.go needs to be fixed though, so let's actually fix it. So when we create this, actually the main handler, we're gonna first create the service, which is a db.new service of a db of a DBS, let's call it database, why not? Database. And database is gonna be a db.new db. The names are not great, but you know, whatever. F. And the file is going to be created in the same way we did before, which I totally lost. So let me get that code here. It was inside of package db db.go. It's this one here. No, it's at the end. This one here. Let's copy that and put it in our file. This is going to do config.filename. It's going to do read write, and that's going to be F, and before f.close, and that's going to be pass F. And all of this is almost happy, except that now we need to pass here the service, and this is happy now. So now what we're doing is we're creating a database, we're passing that database to the service, and then we're passing the service to the handler. Make test, not happy with this. Okay, make test, cool. And now that we have this set up this way, this is when it starts to get fun, because now we can actually drop our code for testing to something way simpler. So right now we're creating a file, right? Do we need a file though? Well, not really. We are actually keeping a read-write seeker. So we could ask to get a read-write seeker. By changing this, nothing breaks, hopefully. I said it too fast. Okay, nothing breaks, everything passes. But now what we can do is this setup, rather than returning a file, could return a read-write seeker. And this code still works. But now what I want to do is, what if instead of creating an actual file and then deleting it, I somehow created something that matched what we want to do. So we could do a new bytes.buffer and then return, for now, a function that doesn't do anything. And I would love this to work, but it doesn't. And it does not work because bytes.buffer doesn't satisfy the seeker interface because it does not have the seek method. Why is that the case? Well, there's an issue regarding this, and I actually link it from the description of the video because it's definitely worth reading. But the whole point of it is that a bytes buffer can drop data. Once you read what was written, later on it could be discarded. And then if you did seek to the back, you might get into the nowhere, right? So that is a problem, and rather than doing that, we don't have it. Luckily for us, my dear friend Matteo Manetti, also known as Matetti, created this package, file buffer. And a file buffer.new of a slice that could be empty, returns something that satisfies read-write seeker in memory. So now we can test this code and everything works. And not only that, but also we can now delete this and this. We don't need to get a tear down anymore. And still everything passes. So now the good thing is that all of a sudden we have since we were able to break the dependency between DB and file, OS file, we can pass anything else, such as a buffer, just a read-write secret in memory. We can do something quite similar to the other packages though, because right now our service, let's see, let's go back here. So our DB depends of iOS seeker, service depends of DB, right? But the interesting thing is that what do we do with DB? Let's try to find all the references to this. There may be many, actually not really. So we have set, get, delete. There's 3 things. So what we could do is do a set, get, deleter, which is an interface that has set, get, delete. And now I'm gonna need to find set, let's see, that is the signature. Set is like this. Get, I'm gonna assume that it returns this and an error, and delete, so that given a key, given a key, and that returns an error. And now we can try to use a set get deleter, and new service receives a set get deleter. And by doing this code now breaks. Recover. Okay, so let's call it something else then, because now it's too long. I don't want to call it DB interface, but storage. Let's call it storage. So recover, I think that just returns an error. So wherever we have that, we're gonna use storage and make test. And the test pass exit offset map is now undefined because service test is doing something weird. Okay, so the problem here is that those 2 types are actually quite interdependent from each other. What we can do is say service db and call it len for how many elements does it have. And then we're gonna need to add it to our database, which is here. So len that returns an integer. And then we're gonna need to go to db.go and add one more method. I'm just gonna add it here. db len that returns an integer, which returns the length of db offset map. And I'm not gonna document it because that's not my problem. But now we do make test, we're able to see that they're separated. So, and the last thing we might want to do is handler test. So handler.go receives a service. And how do we use that service? So we call this handler. Let's get all the references to that thing and see how we're using it. So set, get, delete. Interesting. So that means that a service is also a storage. So now a new handler, we're gonna pass the storage. So we're gonna say storage, and handler is gonna say storage. And these now breaks, which I'm okay with, because that's not implement. Oh, because we're missing the len method when we are passing what? Oh, the service. So now the service file does not satisfy storage itself. So what we can do is we could simply drop this, and that would work by doing. So now we're doing this is kind of funny. So what is the problem? Storage. So what we've just done is that we're actually doing struct embedding of the storage into the service, therefore exposing the len method directly into the service, and now service satisfies the storage interface because that's struct embedding of the storage. If you did not get that, I'm almost sure I said it correctly, so play it back slowly. Anyway, make test. Still doesn't work because service DB isn't fine. Yes, that makes sense. Service.db. Whenever that's written, that should be now nothing, actually. No, that's a bad idea. That's a really bad idea. Storage. Because otherwise, that's a set. Probably it's gonna go back. Okay, service DB undefined and service test. I'm okay with that. So service.db, that's gonna be service.storage. Make test. And all of the tests pass. Nice. So now, rather than having a chain of dependencies where we have HTTP server, well, a handler, we called it, that depends of service, the service that depends of DB, and the DB that depends of file, we're actually breaking that with interfaces. So now we don't use files anymore. We actually pass a read-write seeker to the DB. We don't use the DB directly into the service. Instead, we use a storage interface. And similarly, we don't use we don't use a service directly into the handler. Instead, we pass directly a storage. And which means that actually we're breaking the links between each other and we're injecting what we want when we need it. Now, if I wanted to change this and say, I want this handler or this service to use a completely different storage, I can just pass whatever I need. And that's the whole point of dependency injection. It makes your code not only easier to reuse, but most importantly, it makes it easier to test. And in my opinion, that's the most important thing you can do with your code, is make it easier to test. That way I can go and refactor and then run make test and be pretty confident that it did not break much stuff. Anyway, this is the end of the episode. I hope you enjoyed it. I am going to send this pull request directly to the author. It will be much more content than this, but you will be able to see the commits, some of them that I sent. So I hope that will be useful. Let me know if that helps or not, actually. I think it does, but let me know. Also, you might have noticed it's Tuesday. From now on, I will be publishing the videos on Tuesdays. Why? Because my company, source.tech, check it out, we're hiring, allows us to have an open source days. And that open source day is on Monday every 2 weeks. That happens to be the day I release Just for Funk, but it's much easier for me to record it while I'm doing that day and then publish it on Tuesday. So that's what we're gonna be doing from now on. So as always, tell all your friends about this video, like it, subscribe, and see you all in 2 weeks.